You can use Slido to ask questions. I think the room is small enough that if you have a question while I'm explaining something, feel free to call me out and we can work through your question in that moment, all right? If it's something that's pertinent to whatever's on the screen, if it's something generic or that I can answer later, then just type it on Slido. My name is Rodrigo. That was a very good pronunciation of my name. People usually struggle with it. I don't really mind, but they feel bad. But this was very good, so I just wanted to acknowledge that. Thank you. And I'm going to give you a tour of the module itertools over the next roughly 30 minutes. And why itertools? Well, because why not? But more than that, because it's important in Python. You have two snippets of code on the screen. One wasn't so big that it didn't even fit. The number here is roughly 1 bazillion or gazillion, I'm not sure what's the technical term. And on top you have range of 10. And the question for you is, what do you think is the snippet of code that's going to run faster? Do you think there's going to be a significant difference? Right, so most of you should be comfortable in saying that these will run roughly in the same amount of time. Maybe it's going to take a nanosecond longer to parse this huge number, but once the number is parsed, once the integer is parsed, then creating these two ranges takes exactly the same time. And that's because range doesn't really generate or doesn't really hold. Wait, I'm clicking buttons, did I? No, okay. Range doesn't really hold the numbers in memory. Range just knows how to generate them when you need them, right? I need a volunteer for a very simple exercise. Don't be afraid. Okay, excellent. I'm going to ask you a favor. I want you to count to a gazillion, but you only give me a number when I ask for it, all right? Okay, so can you give me one number?
1.
One more.
2.
One more.
3.
All right. And my friend here, you didn't have to write all of the numbers up to a gazillion to be able to count to a gazillion, right? You were just counting on demand, and that's essentially what range is doing. And this is in opposition to how lists, for example, work, because lists, they hold their elements there. They have to exist in order for the list to be able to contain them. So this very simple comparison is the key to understanding that there's some laziness in how Python works. Well, some objects, in this case range and other things. I'm not sure, have you heard of the built-in zip? Zip is also kind of lazy. Have you heard of enumerate? It's also kind of lazy. And this laziness, in the sense of generating things on demand, is actually beneficial for you. So it's a good thing in here, all right? And the module itertools is what you use to work with these generic iterables, because these lazy iterables are awesome, as you can see on the screen, and the module itertools just provides tools to work with those things. So that's why you should really spend some time studying the module itertools, because there's 20 tools there, 20 things that you will not use every single day, but that whenever you need them, it's excellent that they're there, because they're very useful and most of them are very general purpose. So this is a slide you should all take a picture of, but you can also save it in your head, that's fine. And then let's take a look at the menu. Oh, right, by the way, yeah, I knew I was going to forget that, so that's why there's this slide here. There's a bunch of stuff inside itertools. There's 20 of them. I mean, 20 is still a number you could kind of memorize if you really wanted to. That's not the point. We're going to be taking a look at not everything, but roughly half of the things there. And the objective is not for you to memorize every single thing I say. I just want to expose you to different tools so that you get an idea that, okay, there's something in itertools that kind of does that. So that next time when you need it, you have the trigger, oh wait, I've seen this before. Let me go look it up on the documentation, not with an LLM. Read the documentation, it's safer. So that's the idea. Don't memorize everything. Don't worry about taking notes about everything I say. Just let yourselves be exposed to these ideas. Right, so this is the menu. This is everything that's inside the module itertools, or at least the public stuff. And this is messy. Well, it's not super messy because I aligned them neatly, and they're also ordered alphabetically, so you're welcome. But one thing I think helps is grouping these things. If you group them, you leave T in the corner, that's fine, but then all the other 19 things, you can kind of group them in three, well, if I knew how to count, in five big, sorry, this was not scripted. I just messed up the numbers, and I studied maths at university, so yeah. There's 5 groups of iterables that will, I think, help you figure out what's in there for you to use. And the 5 categories, well, you can all read, but there's filtering iterables that will take something like, when I say the word iterable, are you comfortable with what it means? Well, just for the sake of the recording, an iterable is something like a list or a range, something that you can iterate over, something that has a beginning and you can go through in a for loop, for example. So your filtering iterables will accept an iterable and some way of choosing what elements to keep. Your combinatorial iterables are iterables that will do some sort of not so fancy mathematical operation on your iterable, on the elements. They will be combined or reordered or shuffled in some neat way. There's these infinite iterables at the bottom, 3 of them, that produce infinite streams of data. Pretty much like when I asked one of you to count to a gazillion. If I just said, please count to infinity, that would have also worked, because if I only ask for numbers 1 at a time, we could have stayed here forever, but also it works, because whenever I ask for a number, there's always a next one, all right? So there's infinite iterables, these are, you can have them, and this infinite category lets you work with them. There's the reshaping iterables that takes something and just builds another iterable with a different shape, and then there's these complementary iterables that are kind of tools that do something similar or opposite to another tool that Python also has. For example, zip longest, can you guess what's the built-in that's related to zip longest? You folks are good. And what's the tool related to star map? Yeah, so you get the gist, all right? So let's take a look. Let's take a look at the combinatorial iterables. Well, not all of them, but a couple. Let's take a look at combinations. So I like this one. There's a snippet of code on the screen, and what I'm defining is a list with some ice cream flavors. And then if I ask the question, if I want to have an ice cream with 2 different flavors, what can I order? Then this is what combinations tells me. I'm allowed to combine the 3 flavors in different ways, but I only want 2. So this is what I get with combinations. And the output would be the 3 different possible pairings without any repetitions. Does it make sense? Excellent. Now, permutations, this is a word that has a very well-defined mathematical meaning, and that's exactly what this thing does. If you give it something like a list, for the sake of simplicity, I'm going to be showing most examples with things like lists. But again, the point of itertools is that they really work with any iterable you pass in. It doesn't have to be a list. It might be one of those lazy things, for example. And that's a very important feature of itertools. It's the ability to work with these generic constructs, right? With these generic iterables. And so if I want the permutations here, bless you, the question or the answer that this gives me, or the question that I need to ask in order to get this code is, if you get some ice cream on a cone, the flavor that goes in the bottom actually matters because it's the one you'll be having last, right? This is the stuff I think about. And so the question would be, if I have these 3 flavors at my disposition, in what different ways could the ice cream be served on a cone? And that's what I get. I could have chocolate at the bottom and then vanilla or strawberry on top. I could have vanilla at the bottom and then chocolate or strawberry on the top, or we can just go on. All right, so this is what the permutations do. Yeah, are we good? Okay. And then there's products, and the product will take, now instead of taking a single thing, I have ice cream flavors. Now I'm going to take two different things, for example, the number of scoops I feel like having and whether I want it on a cup or a cone. And now I can combine everything to figure out how many different orders I could have. So I get either 2 or 3 scoops, either on a cup or a cone, and this builds all of the combinations. And this might all be feeling very mathematical, because that's kind of where it's coming from, but this is practical outside of maths. You just have to pay enough attention to figure out that that's the pattern you want. For example, for products, which I think if you only learn about one, let it be products, because when you have 2 nested loops, and you're doing something with the elements from both, if the loops are nested and if they're independent, notice how the second loop does not depend on the first one, but they're still nested. You can rewrite this as a product. Now, Rodrigo, why are you complicating your code? Well, if you have a file, and then there's a class, and then there's a method, and then there's a context manager, and then there's an if, and then nested loops, the nesting is very nested. And that's the technical term. And when nesting increases, you have to keep track of more ideas, more things, there's more context for you. And so if maybe not 2, but if you had 3 loops, this would still work. And now you're saving 2 levels of nesting. So that's kind of helpful. And also, maybe you don't really need the loop. Maybe you can do something else, some other operation. And this product just gives you the object that represents this idea of combining things. Right? So it's not a matter of complicating the code. I wouldn't argue I'm complicating. If I was teaching a beginner, maybe I wouldn't start here. But if I'm working with a team of experienced developers, there might be arguments in favor of this, and situations where this is definitely, undoubtedly a good idea. This is just for you to see that it doesn't have to be math related for this to be useful. Great. So now I want to take a look at our reshaping iterables. And you might have noticed we skipped one, and we will be skipping a couple because I don't have infinite time. Lucky for you, unlucky for me. Now, chain is kind of nice, because if you have 2 lists, you can sum them together, and you get a longer list with all of the elements from both lists, right? But when you do that, you are creating a new list, and you're spending memory to create this second or third. If you have 2, you're creating a third list, so you're spending the memory to create this list that must hold all of the elements. And for small lists, that's okay, but if for big lists, you might be spending a lot of time or a lot of memory. It's not necessarily ideal. So when you want to go through a couple of lists in sequence, you don't have to really sum them, bless you. You can just go through them in order, because that's what chain does. So what's the output I'm going to get when I change to the next slide? Yeah, don't be shy. 1, 2, 3, 4, 5, 6, right? And for lists, again, you might argue, Rodrigo, why don't you just sum them? Please make it easy for us. Well, fair enough, lists can be summed, but there are other iterables that cannot. If you have 3 files and you want to go through their lines in a row, you cannot sum files, but you can chain them together, for example. All right, so that's what chain does. And chain has a second form, which is kind of neat. Notice how I have 3 separate lists, but maybe I have a single list with nested lists, or a list of files. So I have a container with the things I want to go through. Then I can use chain.fromIterable. It's the same idea, but in here, the things I want to go through, they're all inside something like a list. And the output will still be 1, 2, 3, 4, 5, 6. Is this making sense? Great. You're either amazing, or I'm amazing, or all of us are amazing. Let's go with that one. Great, so now I slice. I just said that when you're working with lists, you can sum them, right? But there are other things, other iterables that you cannot sum together. And there's all sorts of neat operations that you're used to doing, like slicing lists or slicing strings, that don't necessarily work with these general iterables. And iSlice, you probably can guess what it's about to do. It lets you slice quote unquote. It lets you slice things that are not sliceable. For example, here, I have this product of two ranges because I was playing this battleship game, do you know it, where you have to sync the ship from other folks. That's a 10 by 10 board. And so there's coordinates that go from 00 to 99. And I'm writing a bot that plays it for me. So I needed to have a way of talking about all of the coordinates. But in fact, I only wanted to print the first few to make sure that it was working well. And so I wanted to slice it. But this product thing, because it's general, I cannot slice it. So this gives me a type error, I think. It gives me an exception. So what I need to do, instead of slicing with this syntax, what I do is I use iSlice. Someone's phone just died. I use iSlice, and that lets me access only the first, in this case, 10 elements. So that's the idea. You probably managed to guess what I was about to do with the name, right? Great. Now, was there something else I wanted to say about iSlice? I can't remember, so let's pretend I didn't. Honestly. Yeah. Oh, no, I know. It's irrelevant. Let's skip it either way. Great. So then pairwise. I like pairwise. It's at the end because I'm doing this alphabetically because reasons, but I really like pairwise. So who's used a pattern like this? You zip, and then you have a list that you slice to ignore the first element, and then you slice it again to ignore the last element. So only one person. I know this isn't a huge crowd, but this is a fairly common pattern. I'm creating pairs of adjacent elements. Hello from and from Bologna. Slicing here, well, not only does it only work when things are sliceable, and we know that not every iterable is sliceable, but I'm also creating copies of the list, because slicing, sadly, it isn't smart enough to figure out, or maybe not necessarily sadly, it's just the way it works. It's creating a copy of the list. It's not like a view or a whatever you may call it. It's a copy. So you're creating copies, and if this is a long list, this is bad. So that's what pairwise does. It walks through your iterable, but in pairs of consecutive elements, or in pairs of adjacent elements. Maybe that's what I wanted to say. So this is faster because it's not creating the copies, and it's neat because, no, it's actually the same as zip. Yeah. All right, so the advantage here mostly is it works with general iterables, not necessarily only with lists or strings that you can slice. Questions about pairwise? Nope. I thought this was a fairly common pattern, but apparently it isn't. Someone enthusiastically nods here. Let the record show that someone was nodding very enthusiastically. Great, so now let's look at these. These are fun. Infinity sometimes messes up with our heads. The idea is you don't really want this to go on forever. You just don't know when you want to stop. So it's good that you have something that just keeps going. And count is essentially like a range without a stop. That's what count is. A good example would be if you wanted to create an ID generator. You can create a counter, and then whenever you ask for the next element, we do what my friend here was doing. It just gives you the next number. If I create 3 sandwiches and I check their IDs, then I get 0, 1, and 2. And this goes on forever, because when my program is starting, I have no idea how many sandwiches I need. That's the idea. Now, cycle is also very interesting. Have you ever had something like a list and you wanted to go through all of the elements and then again, and you end up doing this trick with the modulus and with the modulo operator and the indices? Yeah? No? All right, some say yes, some say no. Fine. You don't need the trick anymore because you have cycle. So cycle will take an iterable and it will cycle through the elements. I know. Half of my talk is irrelevant because the names tell you what they do. But I'm here either way, so yeah. So for example, for Nicholas's talk, this was created today, so it was very relevant. If you have some chicken words, if you didn't watch the keynote earlier this morning, go watch it. If you have some chicken words and you want to create sentences with these words that go on and on forever, you can use a cycle. Now, like I said, cycle is infinite, so you don't really want to run this, because this will go on forever. The point is typically you stop Maybe you want a sentence that has a length of 8. So you use islice, you slice it, and then you get your chicken sentence. And one really neat thing, and I've been thinking about this a lot, and I haven't yet figured out how to express this idea, but there's some elegance to the way that these tools compose with each other. And the fact that all of these 19 iterables, plus the t that's in the corner, all these 19 iterables, you can use them with each other. And it's common for you to use more than one together. And the fact that if you learn about generators, if you haven't yet, go learn about generators. When you use generators, you get to compose them together and you pipe them together, and you get all of these memory and computational time benefits. I find it very elegant because everything just works. And this was just a small example of how you get these objects, these iterables that you build, and then you can use them in different places and you can shuffle them around. And so there's always different ways of writing either the same or similar things. That's why I had this in here, this transformation from the loop to the join. Just a small example, but you can move things around, put them in different places. Great, so now we have these filtering iterables, and compress is kind of neat, but I'll skip it. And also drop while and take while. I like the fact that they're kind of opposite to each other. They complement each other. And because I like them so much, I will skip them. So let's just talk about filter false and the obvious thing that is probably related, filter. Now, who thinks filter is completely irrelevant because of list comprehensions? Just one person. Okay. I'll fight you later. I don't think, okay, so I was expecting a stronger opinion against filter. I'm glad I don't have to convince you that filter is still sometimes usable, or useful, sorry. Still sometimes useful. So what I have here is a small list, because I didn't want to write a big class for persons, and a small function that checks if this person is an adult by Portuguese standards. So the 18, when you're 18, you get to vote, drink, go to jail, all of those fun things. Now, using filter, the built-in filter, and running this code, what's the output I get? Right, so if I filter, if I use the function isAdult, which I'll call a predicate, if I use the predicate isAdult on people, and if I filter with that predicate, I will get everyone that's of legal age to drink and go to jail and whatever. So that's only N in this case. And so what filter false does is give you the opposite. If you have a predicate, it returns the things that are false under that predicate. And the only reason you have this in itertools is in case you do have a predicate, you don't have to write like a lambda function, like lambda person, colon, not is adult. That's cumbersome. That's why you have filter false. Now, if you don't have a function that already computes the predicate, and if you're just writing an expression, then you don't need neither of those. You don't need these things. You just write the expression and your list comprehension or whatever. But if you already have the function, because it came from elsewhere, because it's in a library, whatever, then filter and filter false are equally useful and not useless. That's my argument here. Great, and now there's these complementary tools that, again, complement some other tool that you already have access to, and they either extend it or do something similar, but in a different way, and that's what ziplongest does. If you have, again, more or less the same data, 3 names and 2 ages, if you use zip to go through the 2 iterables at the same time to combine the names with the ages, what's the output you get if you use zip? Yeah, so zip will stop at the shortest iterable. And you get Harry and Anne. By the way, zip now has a strict keyword argument. If they're supposed to have the same length, set that to true and it will error if they're not the same length. But sometimes it's okay for them to have different lengths and you stop at the shortest one. Who can guess what zip longest does? What's the output I get if I use zip longest instead of zip? Yeah, I also get George, but the default extra value is none. Yes, that's the default. You can customize it by setting fill value equals to something. There was a raised hand in the back. Do you have a question?
No, that's fine. I was just going to say if you don't.
Yeah, okay, excellent. So they were agreeing with me, which is good for me. Nice. All right, we're essentially out of time, so let's conclude the talk shortly. I've ignored T for now, because the 19 things over here, they're all iterables, and T is the only thing that isn't. It does something quite funky, because it seems to go against the very nature of iterables and this idea of laziness. So let's talk about it, but let's maybe do it next year. Because it's a very interesting function, but it would take a whole talk to talk about it. So let's avoid it altogether. So these are the, I don't know, however many things we've taken a look at, maybe 10. I'm not going to try to count again because we already established I can't. And these other ones are the ones I didn't even touch upon. So there's lots of stuff, even the ones I told you about, some of them have keyword arguments I didn't even mention. So there's stuff you don't know yet they can do. So I definitely didn't teach you everything, I just gave you a taste. And now the question is, how do you take these things and write good code with them? Again, like Nicholas said, first you write bad code with them, you try these things out, you get a feel for how they work, and then eventually you realize, okay, this sucks in this context, but it's really nice in this other context. That's the only way to go about it, I'm sorry. Or if you know of any other way, please tell me, because I only know about this one. Right. So for the 9 or 10 things you didn't have a chance to take a look at, this QR code will take you to an article where you have all these 20, T included, with a small example for each. No, I just lied, sorry. So the QR code, apologies, the QR code will take you to a feedback form, to a short feedback form for the talk, and if you fill it, then you get the link to the article. But I will also share the link to the article directly on Discord, so if you don't want to fill the form, it's fine. I do appreciate it if you do. And I guess that's it for time. Let's see if we have any questions. Otherwise, thank you so much for your attention.
We have a little more time, so yes, because there's lunch later. So
yeah, but I don't want to keep anyone from the food. From having lunch. That's a bad idea.
So first question: which tool did you use to create these cool slides? That was mostly voted. But just kidding.
It's called Snappify. S-N-A-P-P-I-F-Y. I used to have a slide with a name because I used to get questions about it. And then for some reason I dropped the slide. Yeah, it's called Snappify.
And now to the...
Sorry, I'm on top of you, apologies.
No worries. So now the real questions. I mean, this was real too, but... ever considered submitting a PEP for creating, organizing the groups you mentioned?
No, I have never... Was the question I considered?
If I never considered
it. I can't claim that there's no way I can copyright this division, right? Let's go back maybe to the full one. The other day I spent way too much time writing about Python and thinking about Python and thinking about how to teach it. Way too much time. And I realized that there were relationships and similarities among these different tools, and I just figured, because I never knew, I could never memorize them. Well, maybe if I try to split them, it makes sense, and I came up with this. I'm not necessarily the first person ever to come up with this division. I don't know if it would be useful in the documentation or not. Maybe yes. They already talk about the combinatorial one, so this group was already made for me. I don't know, does it warrant a PEP? I don't think so. Maybe the documentation could include these groups. we'll see. Yeah.
Okay, thank you. And then, do you usually use them to create some data for testing? Well, yeah, I guess the tools.
Yeah, I do. When you have functions that take multiple parameters or multiple arguments and you want to create different combinations of arguments, I very often use either product or permutations, but typically product, to create parameterizations. If I have a function that takes integers and strings, I'll write some integers, I'll write some strings, and then I use product to combine all of those. And I get a bunch of tests for free. So yeah, I do.
Okay. And the last question, I think we can leave for lunch break. Because, well, do you want to ask a question? Because it was a provocation, the last question. It was, what does T do? So.
Okay. So let's go with your question, maybe.
No, I'm just, everything here was lazy and nice to basically work with, but how's this with debugging, right? Because like if you use generators and everything lazy and so on, right? You have to jump through different parts of the code all the time. Like how do you deal with that?
Well, if you have, are you asking if you have, for example, generators, you can step through your own generators?
Yeah, I mean, you always jump through different parts of the code. Like you're somewhere and when you call next on something, you have to know that that's coming from a completely different piece of the code base where the iterable was defined, maybe 5 steps behind.
Right.
So you don't know actually where stuff is coming. It just makes, like, all of this is, for me, made life a living hell a few times.
Okay, well, I don't really know what I can tell you. I get that it might make it harder to debug things. If all of your functions are eager, then it's going to be easier to debug because everything happens sequentially. But if you want to write code that is slightly more efficient, because now you're piping things with generators or using tools like these, then maybe making it slightly harder to debug is the price you have to pay. Things like using iSlice can help you debug. If you have like a long pipeline, you can just slice to get the first few elements to take a look at it. If you learn how to use the built-in next to get one element at a time, that might help. But yeah, using these things does not come, it's not 100% free. You need to be comfortable with these ideas. Does that help?
Yes.
It doesn't. Let the record show it doesn't. But yes.
So thank you, everyone. Thank you, Rodrigo.
Thank you.